alaikum and good night as well. It's quite late, I think about 11:35. But before time to say good night, we have to go through a lecture. Today our lecture is about the equilibrium constant. In our previous lecture, we had studied about the equilibrium constant expression, which is equal to product over reactant, and we practiced different equation from which we derive the equilibrium constant expression in this form. So basically this is a small overlook from our previous lecture. Now let's come towards the today's lecture. Okay, our today lecture is to find out the value of Kc, and here are some problems, sample problem from where we derive the value of Kc. The problem is for the decomposition of N2O into nitrogen and oxygen, means here N2O decompose into nitrogen and oxygen. The concentration of N2O 1.1 mole decimeter cube, N2 3.90 mole per decimeter cube, and oxygen 1.95 mole per decimeter cube. And we have to find out the value of Kc from these values, given values. Okay, now this is our given data, in which N2, the value of N2 concentration is 1.1, N2 is 3.90, and O2 1.95. So from the given equation, we know according to the equilibrium constant expression, the product is our numerator and N2O is our denominator. So according to this, the value of N2 is 3.90, O2 1.95, and N2O is 1.1. And we know that the moles become the powers. Mole becomes power. So by solving this, we got this answer 29.605 over 1.21, and our answer is 24.5 mole per decimeter cube, which is basically the value of Kc. This is our first problem. For better understanding, the second problem is hydrogen iodide decomposes to form hydrogen and iodine. Equilibrium concentration of Hi is this, equilibrium concentration of H2, and iodine is this. Means this is our equation according to the given condition, in which Hi, hydrogen iodide, decompose into hydrogen and iodine. So by putting the value according to this equation, we find the value of Kc. We know according to the per statement, the value of H2 and I2 is this, and the value of Hi is this, and we know the mole becomes power. By putting this value, we got the answer 0.019 mole per decimeter cube, which is the value of Kc. Okay, I forgot to write mole per decimeter cube is our answer. So in this way, we find the value of Kc in both problems by putting the values according to the equation, and we know the product is our numerator and the reactant is our denominator. Here the product is our numerator and this is our denominator, and the moles become power. Here moles become power, 2, 2, 2, and this 2 is here. Okay, our third problem is a little bit different from the two previous one. In this, we have to fix the nitrogen by the following reaction, in which nitrogen and oxygen combines and form 2NO. And when this reaction takes place at this temperature 1500, the value of Kc is this, and equilibrium concentration of nitrogen and oxygen is this. The value of nitrogen concentration and the value of oxygen concentration, and we have to find the value of NO. Okay, So according to the statement, this is our product, this is our reactant. See, product, reactant according to the Kc, product our numerator and the reactants our denominator. The value of Kc is given in the question, 1.1 10 to the power minus 5. NO2, we have to find this value of NO2, and we know the value of concentration of nitrogen oxygen, both are given here. Okay, now what we have to do, we take this NO twice here, this side, and these three values, they come side by side. After multiplying these three values, we get the answer 1.9 into 10 power minus 11. This decimal move one digit before, due to which the value decrease. Minus 11 becomes minus 10, and it becomes 1.19 into 10 to the power minus 10. Now here is NO twice, means we have to take the square root as well, as we want to find out the value of NO, the molar concentration of NO. So by taking the square root we get the answer 1.09 into 10 to the power minus 5 mole per decimeter cube. So the difference in this question is we don't have the molar concentration of this NO2, and all we have to do is to take this value at this side and then multiply all these value at one side. And one important thing is we have to take the square root as well, as we want to find out the value of NO, not NO twice. That is why we take the square root on both sides. Similarly, there is another problem number 4. Here nitrogen reacts with hydrogen and form ammonia, and in the equilibrium mixture the concentration of nitrogen is this 0.31, and concentration of hydrogen is this, and the value of Kc is this. Again the same issue, in this we have to find the value of NH3, and according to the equation, NH3 is our product and N2 and N3H2 is our reactant. So we have written NH3 in the numerator and N2 and H2 in the denominator. Same way it comes at this side, they become together. Putting the value, we got the answer 0.019. Again we have to take the square root. After taking the square root, we get the answer 0.13. So by interchanging the values here, we can find the molar concentration of any reactants or the product. And this problem number 4 and the problem number 3, they are similar in their method, because in both problem what we have to do, we have to find the value of product C, 2NO, and again in this 2NH3. So in this way